We have formula for density variation with temperature. It is rho equal rho naught 1 plus gamma delta T, where this is density at 0 degree Celsius, and this is at T degree Celsius, and this is called uh, volume thermal coefficient of volume expansion, which is given here. So this is gamma. So we can put the value 13.6 10 to the power 3 1 plus 18.0 10 to power minus 5, and rise in temperature is 50 degrees Celsius, because initial temperature was 0 and final is 50. So delta T is 50 minus 0, I mean 50 degrees Celsius. So I can put here this one, and that's equal to 13.6 10 to power 3 and that's equal to 1.009, and that's equal 13.478 into 10 to the raised to the power 3 kg per meter cube, which can approximately we can write it as 13.48 into 10 to the power 3 kg per meter cube. So this is the answer. The difference between the length L1 of brass rod and a steel rod of length L2 is constant at all temperature. The coefficient of linear expansion of brass and steel are alpha and alpha 2 respectively. We have to find the relation, which one is correct. So we have two rod. This one has length L1 and another is suppose has length L2 at some temperature. Suppose it is at T temperature, and when temperature is rise, suppose this has length L1 dash and this has length L2 dash. So L2 length increase to a new length L2 dash, and L1 length increase to a new length L1 dash. In the question it is given that the difference of these two length is independent of temperature. I mean it is the same at all temperature. It means L2 dash minus L1 dash is constant, I mean independent of temperature. It does not depend upon temperature. So from linear thermal of expansion we can write L1 dash as L1 1 plus alpha 1 delta T, and these two lengths are at suppose T plus delta T, and L2 dash can be written as L2 1 plus alpha 2 delta T, and we can put the value of L1 and L2 in here. So L1 L2 1 plus alpha 2 delta T minus L1 1 plus 1 delta T, and this is constant. So this can be written as L2 plus L2 alpha 2 delta T minus L1 minus L1 alpha 1 delta T equal to constant L2 minus L1 plus delta T L2 alpha 2 minus L1 alpha 1 is equal to constant. Here the expression in the left side of equal sign, there is a delta T, I mean change in temperature. So this expression to be constant, this must be this thing in bracket must be equal to 0, because if this is 0, whatever be the value of delta t, this left hand side expression will always equal to L2 minus L1. So this to be independent of temperature, L2 alpha 2 minus L1 alpha 1 should be 0. So this come out to be a relation L2 alpha 2 equal to L1 alpha 1. So this is the correct answer. An aluminum sphere is heated from 0 degrees Celsius to 100 degrees Celsius. The change in the volume of the sphere of radius 10 centimeter. The volume coefficient of thermal expansion is given. Gamma is so much. Now we know that change in volume equal to initial volume gamma delta T. Here V naught is volume, initial volume, which is equal to 4 by 3 pi r cube. Gamma is also given, so we can write here it is 4 by 3 r cube gamma delta T. 4 by 3 into 3.14, and r radius is 10 centimeter. 10 centimeter can be in it is 0.1 meter, I mean 10 to power minus 1 meter. So this is 10 to power minus 1 ka cube, and gamma is 5.4 10 raised to the power minus 5, and delta T and temperature change is 0 degrees Celsius to 100. So delta T equals to 100. So I can write it here as a 10 to power minus 2. So this is meter cube, and 4 into 3.14 into 5.4 by 3 and 10 to power minus 3, 10 to power minus 5 and 10 to power 2. This is meter cube. And if I want to change this meter cube into centimeter cube, I have to multiply by 10 to power minus 6, then it will convert into centimeter cube. So this will be equal to uh, 10 to power minus 3, 10 to power 5, 10 to power minus 8, and so this all will cancelled out, and this come out to be 22.6 centimeter cube. So this is the answer, third one. A copper sphere is heated, then percentage increase is maximum for area, length, diameter or volume. Suppose this is a copper sphere whose radius is r, and delta r by r can be written as alpha delta t. Delta A by A can be written as beta delta T. Delta V by V, fractional change volume, can be written as gamma delta T. For metal, and copper sphere is definitely made of a metal. For metal, we know that alpha is to beta raised to gamma is 1 is to 2 is to 3. So this can be written as 2 alpha delta T, and this can be written as 3 alpha delta T. So this way we see the percentage change or fractional change is maximum in volume compared to area or linear dimension, which is radius. So percentage change in volume is maximum. A pendulum clock run fast by 5 seconds per day at 20 degrees Celsius and goes slow by 10 second per day at 35 degrees Celsius. It's so correct time at the temperature off. So these are the option and we have to choose the correct one. So by what theory? This is a pendulum, and at temperature T its length is L naught and its time period is T naught. So T naught equal to 2 pi under root L naught by G, and at temperature T plus delta T its time period will be T equal to 2 pi under root L by G. By thermal expansion in length, new length is L, and this length is increased from L naught by increment of that much temperature. From the thermal expansion we know L equal to L naught 1 plus alpha delta T, where delta T is temperature increment. So we can write T upon T naught equal to, if I divide this equation by this equation, we get L by L naught, and we have L naught 1 plus alpha delta T by L naught. So we have got here 1 plus alpha delta T. Since this is very small, because alpha coefficient of linear thermal expansion, alpha is coefficient of linear thermal expansion. This being very small, so we can apply binomial theorem. Binomial theorem says 1 plus x raised to the power n is approximately equal to 1 plus nx, provided x is very small. So this can be written as 1 plus half alpha delta T. So this is equal to T by T naught. T by T naught minus 1 equal to half alpha delta T. This equal to T minus T naught by T equals half alpha delta T. This is delta T by T. Change in time period upon original time period equal to half alpha delta T. Now one thing that I would like to tell here, that here this is change in time period and this is original time period. When temperature rises, time period length rises, length increases, so time period will be more. The clock runs slow because time period is more, so it start moving slowly. So clock runs slow, it means it loses time, while if temperature falls, length decreases, time period also decreases, means clocks runs fast. We say clock gains time. Now delta T by T is half alpha delta T. If I take this time t as a 24 hours, I mean if total time is 24 hour, this give the time lose or gain in 24 hour. Now according to the question, the pendulum run fast by 5 seconds per day at 20 degrees Celsius and goes slow by 10 seconds per day at 35 degrees Celsius. So I have written this here also. Pendulum run fast by 5 seconds per day at 20 degrees Celsius. So let the actual temperature at which it gives the correct time is t at 35 degree. Time period will be more, so it slow by 10 second per day, and at 20 degrees Celsius it's become fast moving, I mean it's get 5 second more. So we can write from this equation delta t by t equal to half alpha delta t. T is 5 upon, this is 5 second out of 24 hour, I mean 24 into 60 into 60, this equal to half alpha, and this will be equal to t minus 20. I mean 5 second it become fast by 5 second at 20 degrees Celsius, but the actual temperature is T, so change in temperature will be this much. This is equation number 1, and the other one is it gained by 10 seconds, so we can have 10 second upon 24 into 60 into 60 equal to half alpha 35 minus T. So this is equation number 2. So dividing these two equation, we can have this will be 1 by 2, 5 second and 10 second, this give 1 by 2 ratio, and this will cancel. So t minus 20 upon 35 minus t, this will equal to 35 minus t equal to 2t minus 40. So 3t equal to 75, I mean t equal to 25 degrees Celsius. So this is the time at which it gives the correct, it is that temperature it shows the correct. So the answer correct is 25 degrees, this one.